Hello students, so this was the problem given to you as your home task. So I am trying to solve this problem. So when you get this type of problem, you should be able to find out with which theorem you are going to solve this problem. So first you see in this diagram that there are two voltage sources. So this can be easily done using Kirchhoff superposition theorem. Then you have three loops. You can easily do it with Kirchhoff's voltage law, but it is very difficult to apply here Kirchhoff's current law. So first, also you see that there is a delta here. This is a delta. This one is a delta, right? You can convert this delta into a star circuit, and you can easily solve this problem without using superposition theorem. So let us see. And if you want to apply Kirchhoff's current law to this problem, you have to do that. You have to convert this delta into a star. So let us see how to do that. So delta will be like this. Convert this delta into a star, and the circuit will look like this. And the circuit will look like this. So this is your circuit. Now, what are the values of these three resistances? They are not now 30 ohms. So if you have convert a delta into a corresponding star, then these values will become 10 ohm, because all the three values were 30. So these three values of star will be 10 ohms each, because the corresponding deltas were 30. Okay. So now see, this is a very simple circuit, and finally this circuit can also be replaced as this. Right? So you can directly use only one resistance. You can have only one resistance. So in this circuit, if you apply, let me redraw it. So this has become now 20 ohm, because 10 and 10 ohms were in series. This is 10 ohm and this is 10 ohm, right? So you get a very simple circuit. This circuit you have solved using KCL. So if this is A node, you can use A, let the potential be VA. So if this is I1, this is I2, and this is I3. I3 is nothing but your IL, so let it be IL only. So I1 plus I2 is equal to IL. So the equations, I1 is 20 minus VA by 10. What is I2? 30 minus VA by 10, and that is equal to VA by 20. That is equal to VA by 20. Okay. So you get VA, by solving this equation, you will get VA is equal to 20 volts. So if VA is equal to 20 volts, IL is equal to 1 ampere. So your answer is 1 ampere. So your answer is 1 ampere. Now the same problem could have been done using superposition theorem. You can use superposition without converting the delta to star, or you can do this by converting the delta to star. You can do it with superposition theorem. So if you do it with superposition theorem, then first neglect the short the 30 volt. Let me short the 30 volt. Let me short the 30 volt circuit. So here you have a short circuit. Here you have a short circuit. So what is the current through this? You can easily find out the equivalent resistance. Equivalent resistance is 10 plus 20 parallel 10. 10 plus 20 parallel 10. And that is coming to 200 by 30, 20 by 3, 50 by 3. 50 by 3. 50 by 3 is your equivalent resistance. 50 by 3 is your equivalent resistance. R equivalent is 50 by 3. You can calculate it. 50 by 3 ohms. So current, this current, let it be I. So this big current I is 20 divide 50 by 3. So 6 by 5. 6 by 5 ampere is the current through this. So what is IL? IL is 10 by 10 plus 20 into 6 by 5. So that comes to 10 by 30 by 3 to 0.4 ampere. It comes as 0.4 ampere. Now, if you do not short this, if you are not shorting this 30 volt and you are shorting this 20 volt, you are shorting this 20 volt, then again R equivalent is same. Again R equivalent is 10 parallel 20 plus 10, right? And that comes again as 50 by 3. So your now current I flows from here now. Now this is current I. So if this current I is, this is due to this I, what is this I has now become 30 by. So this is 30. Right. So 9 by 5. This becomes 9 by 5 ampere. This becomes 9 by 5 ampere. So IL for let it be IL double dashed, and the initial was let this be IL dashed. So now IL double dashed. What is IL double dashed? Again 10 by 10 plus 20 into 9 by 5 into 9 by 5. So it becomes 0.6. So it is 0.6 ampere. So it is 0.6 ampere. So what is IL? IL is the sum of, according to superposition theorem, IL is the sum of the currents flowing in the same circuit due to each voltage source, each active source taken separately. So 0.4 plus 0.6, it is coming as again 1 ampere. So I hope you understood how I did this problem using superposition theorem and KCL using delta to star conversion. So this is how you should do your problem. In the next class, I will try to explain the same problem using Thevenin.